Variation is the bane of supply chains and operations. Not just variation, but also the uncertainty, not knowing what the demand rate will be tomorrow, next month, next year, nor what the supply availability will be. Supply chain managers need to accommodate for variation and uncertainty. It's almost their main job. If we knew we would always sell 50 things each week forever, and therefore we needed to buy those 50 things per week forever, and we knew that our suppliers could always deliver them exactly with a 1-week lead time guaranteed forever, well, then, aside from the truck driver, the whole supply chain department would really not have a purpose. Variation and uncertainty means supply chains need to build in expensive buffers to protect themselves. Buffers of time, inventory, and capacity. We need to measure variation and uncertainty in supply and demand so that we can make strategic decisions about how much of a buffer we want to be paying to keep. But what should we measure and how? First, we need to have our demand rate plotted over time. We can plot the rate of our sales or consumption at appropriate intervals so that we can see unexpected changes and trends over time. Self-created upper and lower control limits will show us when we need to start taking serious notice and try to work out what's going on. Similarly, we can measure variation of supply by plotting replenishment lead times. Every time you place an order for more stock, record how much time it took from order to delivery. Combine these two measures, the replenishment lead time and the demand rate, to assess your lead time demand for every time you make a replenishment order. Your lead time demand is how much you sold or consumed in the time from when you made your replenishment order until it arrived. This will be crucial for calculating your reorder point and safety stock, and it is a function of both the variability of demand rate and the resupply lead times. How can we quantify variation? The most widely used measure of variation is standard deviation from statistics. In this graph, I've calculated and plotted the standard deviation of demand, shown by the green line. Whilst the average demand is not really changing, the variation, and therefore the standard deviation, has clearly increased throughout the year. We can do a similar analysis on the supply side for our replenishment lead times and lead time demand. Variation and uncertainty are critical factors in supply chain and operations management, and are a principal cause of the complexity and cost. By understanding them, we can better plan with the necessary buffers of time, capacity, and inventory, whilst also making an active effort to reduce variation and improve our forecasting.